Hi, I'm Carl Franklin. In this episode of Blazor Train, I welcome Rocky Lhotka for a very interesting session. And how appropriate is the word session? Because we will be talking about state, particularly how we lose state when mixing rendering modes in the same Blazor Web App. That's right, injected scoped services get reinitialized whenever you switch pages that have different render modes. Cascading parameters like my cascading app state will even turn null. Global mode is your only hope for stateful applications right now. Now, we recorded this in late January 2024, but there's no indication that this bug will be fixed before .NET 9. Fortunately, Rocky has forged a workaround in his awesome and still free CSLA.NET, which he's going to show us. Fixing state in Blazor Web Apps is coming up right now, right here on Blazor Train. Hey, it's my old friend Rocky Lhotka. How are you doing, sir?
Hey, glad to be here.
I'm glad to finally get you on the show. I wish it was under better circumstances, but we were talking on .NET Rocks just the other day, and I was sort of talking about a problem that I had found with Blazor Web Apps in .NET 8. And you said, oh, have I got stories for you, right?
Yes, indeed.
Yeah, so we talked about this bug, and it is a bug. It's not behaving as anyone would expect. And you actually have a solution for it, which we'll talk about later. But first of all, tell us what this problem is.
Well, the problem that I ran across, and I suspect a lot of folks will, is they try to build quote-unquote real apps, like line of business type apps, is that in the new Blazor rendering model in Blazor 8, where you can have pages that are static rendered on the server, and then other pages that are rendered in WebAssembly, and yet other pages that are server interactive, and you can have auto pages that will server pre-render and then switch to WebAssembly.
Server rendered mode first, and then WebAssembly. And I actually talked about that bug because that wasn't working. It wasn't actually ever giving you server rendering. It was waiting until WebAssembly was downloaded. So you went from static rendering to WebAssembly in auto mode, making auto mode superfluous. So they did fix that. But this one is different.
Yes. Well, and you say they did fix it, but in practice, they will have did fixed it.
Well, they fixed it in global mode.
Yeah.
If
whatever fix is not rolled out yet to per page mode.
No, and in fact, this is a different problem altogether. So the problem in per page or per component mode, no matter what interactive render mode you choose, as far as I know, is that server static side rendering happens. You get your injected objects, no problem. But then as soon as it renders, on after render async happens in first render, boom, they all go to null.
This is the issue here, the cascading parameters turn null?
Yeah, that's the one that I entered. I did some tests, and I found that my good old cascading parameters that I like to use for app state and things like that went null after the first render. But you entered an issue a while ago about dependency injection.
Yeah, the whole thing some of it, I think, comes down to the way that the server pre-render, well, just the way the rendering all works in Blazor 8. And so if we step back a little bit in Blazor 6 and 7, could depend on having a dependency injection scope available for the lifetime of a user sessions, shall we say. So when, if I'm using Blazor server and the user connects, then a DI scope is set up and for that user. And in fact, that's how Blazor does isolation for any sort of per user state. The identity, everything is done using DI scopes.
Scoped services.
And of course, in WebAssembly, really there's just only one DI environment at all, but you can think of it that you had one consistent scope for the life of the WebAssembly app. And so what this meant was that we could always use any sort of scoped service to maintain something that had to be per user and available through the life of the app.
Right.
And with Blazor 8 and the new dynamic rendering mode, I guess is maybe the way to put it, DI scopes are created and destroyed just like crazy. So when you use a server, a static rendered page on the server, a DI scope is created and destroyed and only exists for the length of rendering that page, which is sub-second, right?
Now this is when we're in per page or per component, right? Per user state management is out the window. But is it your experience, and it is mine, with the cascading parameters anyway, that if I go to global mode, everything works all the time. It's only when I'm in per page or per component that it doesn't.
Yeah, and yes, I believe that's true. I've spent a lot more time trying to solve this per component thing than I have the global thing. But that's the thing about the cascading parameter. If I go to your GitHub issue, the way cascading parameters appear to be implemented is that they throw the parameter value into a scoped service.
Yeah.
And that's why you're seeing
they do.
The issue that you're having here is because the cascading parameter gets thrown into a scoped service, which might exist for a fraction of a second, or it'll exist for the life of one page. But as soon as the user navigates to a different page with a different render mode, and so to make things really complicated, if you're creating a WebAssembly Blazor app and you have an ASP.NET Core server behind it, it will do server pre-rendering by default. So it'll pre-render the page, which creates and destroys a DI scope. Then it'll re-render it using WebAssembly, which creates a scope that now lives for the length of the page.
Except my experience is that it's null as soon as that first render.
Oh yeah, well that's
along.
The thing, is because your cascading parameter was maintained in that first DI scope that got destroyed.
Right. Yeah.
Yep.
Awesome.
It's a little hard to follow, but that's what's going on. It gets created, it gets put in the scope, and then boom, it's gone.
Can we demonstrate this with Visual Studio?
Well, we could try doing a little coding on the fly.
So we're running my sample app, the repo to which is linked in that issue there. And this is a .NET 8 Blazor Web App. And what I did was I first created it for WebAssembly, but I also added the server components, but it's in global mode right now. But what I've got is a cascading parameter, a cascading app state. And if you look at the code behind for this, all I've got is the render fragment here for child content, and I've got a count property. And it's a backing field, lowercase count, and that gets returned with a get and with a set. After setting the value, we call status change. Very simple. And now if you go to routes.razor in the client, you can see I've encapsulated the router in a cascading app state, right? So then we go to counter. And what I've done with counter is I've got my cascading parameter app state, which I initialize to null, even though I don't really need to do that. And instead of incrementing a local current count, I'm incrementing app state count. And also I have this little trick that on after render, if it's the first render, I'm checking the render mode with operating system.isBrowser. And if that's true, then render mode is WASM, otherwise it's server, and its initial state is render mode is SSR.
So you got server-side rendered static, and then server interactive and WebAssembly. Yeah, nice, okay.
Mm-hmm. So this is set to global mode, and you can tell it's global mode by going to app.razor, and we have set the head outlet render mode and the routes render mode both to interactive WebAssembly.
So that means everything in this whole app renders on WebAssembly with no pre-rendering or anything else.
Well, it's going to pre-render because we didn't specify pre-render false.
Oh, that's true.
So you get the static thing first, but by the time you go to the counter page, it's not static anymore, right?
Yeah, right. It's switched into WebAssembly.
And it's one of those things where you can't even go to counter mode until WebAssembly is loaded, right? If you're pre-rendering, you get this state initially where it looks like you can do stuff, but you try clicking on a button and it doesn't work.
Right. There's a trick too, Carl, that's maybe worth calling out quick, is that what you can do is, like, in your on initialized, you can disable the button or have it start disabled and only enable it on the after render, because static server rendering does not ever run after render.
Yep, that's right. All right, so you can tell it works. Go ahead and click the button and go back to counter. So we'll increment it to 5 or 6.
Oh, look,
there
it's
we
still
go.
6.
And it's still 6 because that is outside of the page.
And to be clear, what happened there is that by the time we were in the counter page, we were completely on WebAssembly, and so a DI scope had been created on a per user basis. Well, for of course it's per user,
right?
And so that state was managed in a dependency injection scoped service.
Yep. So we just delete these render mode attributes here.
Right. Happily deleted.
Yep. And then go back to counter.
Oh, yes. Right. Because we got to.
And we already have this at render mode interactive WebAssembly. Even when we were in global mode, it's redundant, but it still works. So now this is going to take over because we're on a per page or component. It's our responsibility to say what render mode each page or component is using.
Yep.
So we have to say render mode interactive WebAssembly. All right, now let's run it and see what happens.
All right, here we are.
This is static rendered, obviously.
Right, and weather would be stream rendered like normal. But now if we click counter, SSR, oh, object reference not set. This is your bug right here.
So the problem is that app state is null.
Yep, that's exactly it. So this page, so we're clear for everybody, right? When we click from home to counter, you can see that it's rendering in static mode on the server, and that worked. And now what failed was an attempt to render in WebAssembly because your app state didn't carry across, right?
Right. All right. So you obviously have been dealing with this issue for a long time, and a fix for this crept into CSLA.NET 8, did it not?
It did.
Is it a fix? Is it a workaround? What would you call it?
Yeah, I think you could call it either one.
Okay.
I actually wrote a couple blog posts about the issue. I wrote one in October, being frustrated as I discovered the depth of the issue. And then I wrote another one in November when I had created a prototype solution. And I put a lot of detail in here, whatever else that folks can read.
Of course you did.
Yeah, so this was like my prototype idea, right? And it works. It solves the problem. But within CSLA, I put a lot more work into refining the solution to the whole thing. And
so first of all, tell us what you did in CSLA, just overview to make this work.
So the gist of it, since we can't rely on a dependency injection scope to be consistently available, that means that we have to externalize any per user state into some sort of global cache.
Okay.
And so that might be just a collection dictionary in memory, or you might use a Redis cache. I mean, there's all sorts of ways to cache the data, but the point is that it's in some sort of place that's available. So the simplest thing, if you just have one web server running, you're not in a cluster, is just to throw it in a dictionary that is indexed on a per user basis.
Right. And that's obviously running on the server no matter what render mode you're in.
Yep. Right. So step one then is to say, well, what does per user mean? And so that means we need some sort of unique identifier on a per user basis.
Right.
So enter the cookie. So you create a cookie with a GUID to identify the current user session. And then you can always use that value to look up the user's state. And then that all works on the server. So once you've done that, then you can easily switch between static rendered on the server and interactive mode on the server. And it all works because all of them have access to the cookie and to the state because it's right there.
Right.
Extending
the WebAssembly, though.
Extending that out into the browser with WebAssembly, that means that when your page first renders in WebAssembly, it has to have some way to get that state from the server.
An API call, perhaps.
I set up a controller, and it basically just calls back and asks for the state, and using this service. And because, of course, the cookie is still available, it's all good. So we're able to return that state to the browser. And that part actually is pretty straightforward. The real trick is that if your per user state is mutable, right? In other words, the WebAssembly page could change the per user state. Now you have to have a way of updating the master data, which is still on the server.
Well, wait a minute. That sounds like the problem is bigger than I thought. I thought the problem was just on the initial render.
Nope.
When you do these per page or per component. But now you're saying, and I thought I heard you say this before, that it's going null all the time and being built back up and shut down and built up.
Yep.
Like if you switch from counter, which is per page, interactive WebAssembly, over to home, which is static server render, and you go back to counter, it's going to fail again?
Yes. Absolutely right.
Wow.
Yep.
That sucks.
Yep. Because if you're per page rendering, when you go back to home, the WebAssembly runtime gets torn down. And so your dependency and your DI scope goes away. And now you've got that server rendered page. And so when you click back into counter, it's going to rerun it's quick because it's already downloaded everything to the browser, but it's going to restart the WebAssembly runtime. Yeah.
How easy is it to implement CSLA.NET and these features in, say, my demo app? Do you think we could do that?
Yes, we could definitely add CSLA into your app and do it that way. So,
okay. Because now we've got everybody's full attention, right? And they want to know, okay,
sure,
how do I use that? How do I get me some of that? First of all, while you're doing that, I'll just mention that CSLA is a framework that Rocky developed initially in his books and just gave away with his books. And it sort of, developed. He kept doing every time a new version of .NET came out, he'd do a new version of CSLA. It's a framework that does multiple levels of undo, transactions, like all sorts of great things that you need. I think there are binding things in there too, right?
Yep.
Just all the tools that Rocky thinks we should have in our apps. And that's now we've got the .NET 8 version, and no surprise, he's fixing this problem, which is just great. And it's still free. It's open source, right?
Yes, indeed. MIT licensed.
Even better. All right, so CSLA, Blazor WebAssembly. You're adding that.
Of course, I'm using the pre-release because CSLA 8 is still a work in progress. Because, like for this issue we're dealing with, I'm not 100% sure I have it the way I want it yet. Like I keep coming up with ways to make it better, right? So,
fair enough.
All right, so I've added the NuGet dependencies, and then we have to go tell the world that we want to use some CSLA, and we'll do that on the client as well. I didn't quite do this right, so CSLA has a lot of options.
Okay.
And so we need to add Blazor WebAssembly here. And if I go back here, we also need to add server-side Blazor, and I think I forgot to grab one other dependency, and that would be, because this is running in ASP.NET, we need the ASP.NET Core support as well. Part of what CSLA does is it includes code to try and mitigate differences between things like data binding and other issues between, let's say, WPF and Blazor and stuff. So that by itself should make the server-side stuff work.
Okay.
But we actually need to, on the server, go and add a controller, because when we run the WebAssembly, it has to be able to call back. And before we add controllers, then we better make sure that we have, so by default,
Map controllers.
We don't have support for controllers yet. And now I'm going to cheat because remembering...
Because you can.
Because I can. I'm going to go to an existing app and go look at the CSLA state controller.
All right. So it's a very simple controller, CSLA state controller.
Yeah, so this controller, CSLA state controller, but ultimately it is inheriting from, or it's a subclass of a state controller that's provided by CSLA that does all the actual work. This state controller is just a standard controller that inherits basically from controller, then implements an HTTP GET with the intent that when a WebAssembly page first loads, it can call this to retrieve the current user's state. And so to do that, we go out and call something. And so in order to keep this, I guess, kind of maintainable, there's this concept of a session manager. And there is an implementation for the server, which is a session manager that manages session for all users on that server. And then there's a different session manager implementation for WebAssembly. And so it's actually an iSession manager, right? So it gets data dependency injection.
So the iSession manager in WebAssembly is going to make the API call to here.
Yep.
Right.
That's correct.
Yeah.
And
Aren't interfaces wonderful?
And dependency injection for this sort of thing, it's totally awesome, right?
Yeah.
So basically I just ask the session manager for the session, and this is the server-side session manager, and so what it does is it grabs the cookie, looks up the user in the dictionary of states, returns the current user's data, and then because we're shifting control or ownership from the server to the WebAssembly client, I flag it as checked out, so the server understands that it shouldn't be manipulating this user session on the server because we've shifted ownership to the client.
Right.
Then I serialize it. In this case, I'm using CSLA's serializer. In another world, you could use something like a JSON serializer or something like that, but that wouldn't work with CSLA.
Okay.
And then we return, basically the service consumes and returns a byte array because I don't care for it to be human readable.
Yep.
Efficiency is important.
Yes.
So then the other thing that the controller does, and this is tricky, is when the user leaves the WebAssembly environment and returns to a server-side page, we need to send the state back from the client to the server.
Right.
And so there's this put that takes this byte array and uses the byte array, deserializes it back into an object graph, says that it's no longer checked out, and then it updates the session manager. So that now the session manager on the server has whatever per user state was altered on the client. So if we switch back to Blazor 8 test, let's see if this works. See if I did everything right.
So you don't have to change any of the code?
I will have to change your app state code.
Right.
Yep.
Right.
Oh, yep. I just wanted to see if I forgot a step. And so CSLA requires, because it's using HTTP context.
Yep.
Yep. So now you might end up having to edit this part out.
I think people enjoy seeing you debug in real time.
I think you're right. I'm just going to make sure we can run. Okay. Now that we got the plumbing in place, let's actually make it go, right?
Okay.
So there are some limitations to making this work. So first off, if we start in the counter page, the only way to know that a WebAssembly page is quote-unquote done or we've left is for it to implement iDisposable.
Yep.
There are numerous discussions all over the internet talking with Microsoft folks saying, hey, can't you provide us with a better solution to
life cycle,
to know about the life cycle? And thus far we got nothing. So we'll implement dispose. Also, we are going to inject state manager, right? So state manager is the thing that lets you access or work with state.
Okay.
Behind the scenes, it's using different injected services like we talked about. So it acts different in WebAssembly than it does on the server, but you don't care, right, is the idea.
Are we going to have to abstract the properties of app state away into an interface and an implementation in order to serialize and deserialize? Because this is a component.
Yeah, we probably can't use cascading apps. Well, in fact, we're no longer going to be relying on cascading parameters at all.
Okay.
And because
all right,
that was out of scope for me, was to figure right. I was not interested in figuring out how to make cascading parameters work. I was interested in figuring out how to make state work.
Mm-hmm.
And maybe somebody, maybe me, I don't know, could figure out how to merge these two things. But so when this page starts up, it's going to initialize the state manager, which is what will trigger that call to the web service, right? The controller to get that state. And then when the page is disposed, it'll save any updates back.
All right, but we still don't know what we're saving.
Nope. But I'm still not done, sadly, with the bits of plumbing. So if we go to the home page, so the home page, it turns out, so this is server static rendered, right?
Mm-hmm.
So the weather page, is stream rendered, and we actually have to make the home page stream rendered also.
Okay.
And the trick here is that when the user's on this counter page, so here's the counter page, right? And it's running in WebAssembly, the dispose method won't actually run until the next page the user goes to has actually rendered. It's weird, though, because you would think that when the user navigates away from counter to a different page, that it would that would be the end of it. But in fact, like if we navigate to the home page from the counter page, and this is not streamed, what will happen, because I do need to add a little code here, I guess, to make this totally make sense. Let me override on initialized async, because every page actually has to do state manager dot initialize async, which means I need to inject the
you need to add the async keyword to override task initialized.
Good call. And then I need to await this. There we go.
Rocky and I will pair program with you for $5,000 an hour.
It's so much fun, though, right? So basically what happens, this initializes the state manager and the state and all that sort of stuff, right? But when we're coming from a WebAssembly page back to this page, then this has to wait until the state has become available. Because remember, we check the state out to the WebAssembly client. I had that is checked out flag, right? So we can't get past this point till it's been checked back in, but we also won't get past this point until the dispose method on counter runs, and the dispose method on counter won't run until after this page has been rendered. So we're in a catch-22, a deadlock of sorts.
That's why you have to do the stream rendering,
and that's why we end up having to do the stream rendering, is because that allows this page to start rendering so that the dispose can run, so then this can actually work. Yep. And,
ain't async wonderful?
I tell you. And so the same thing actually has to happen on the weather page. Let's see. So the weather page now, stream rendered, brings in state manager, and then we'll grab this, actually, probably just that line, because I think weather already has an uninitialized async.
Yep.
So we'll just make sure we get the state running here. All right. The other thing that I have discovered is that we can't, using this technique, we can't allow counter to ever pre-render on the server.
Okay.
And the reason being that if you navigate between different WebAssembly pages, what happens is you go from one WebAssembly page to the next, and it'll attempt to server pre-render, but the page has not yet disposed. So the state on the server is locked.
Are you saying that every time you go from counter to home back to counter, it doesn't have to download all the WebAssembly stuff again because it's in a cache?
Nope, but
it has to server side render first. And wait until the WebAssembly engine is up and running, and then it switches over?
Yep. Even if the WebAssembly engine's already running,
oh my God,
server pre-render. And yep. And so, so if we look at
this stinks more than I thought it stunk, Rocky.
It is really tricky. Yes. And and this is why CSLA 8 is still a work in progress, because I don't know if I've caught all of the edge cases yet.
Right. And here's the other thing that hopefully, now this is something we should say now, that somebody from Microsoft told you that they were going to push this issue until .NET 9. Is that true?
That is correct. Yes. This is not something they plan to solve in the near future.
So you've basically got at least till November, right?
Yep,
and then there's no guarantee that it'll be fixed in November.
Correct.
Because it really is like a fundamental re-GUIing of the internals, isn't it? To get this to work right.
Well, it is. And, the thing is that, like, why is it that when I leave counter and go back to home, that the dispose doesn't run on counter? Well, it's because there's a JavaScript handoff that's going on within the Blazor JavaScript client library that doesn't allow the WebAssembly environment to dispose until the server page has started rendering. And what this means, though, is that the Blazor environment already does a handoff. They just don't transfer any state as part of it, or at least they won't transfer my state. Right. So my suspicion is that they've already got a lot of capabilities in their current handoff that they could add state transfer as part of it.
Yeah.
I don't know that for a fact, but it seems that way. So maybe they don't even need this controller and some of this other stuff, right?
Right.
So I suspect that they can come up with a really good solution that might be out of reach for somebody like me.
The other thing that I wanted to ask you is, why not for WebAssembly save to local storage instead of going back to the server?
Well, local storage is on the client, right?
Right.
And so you could save it there, but then when you go back to a server rendered page, then it basically inverts the problem, because now the server rendered page would have to call the browser to get that state and pull it down.
It's fine if you were only using WebAssembly, but if you want it all, as you said in .NET Rocks, you want to be able to say this component uses server, this component or page uses WebAssembly, this one's server-side rendered, and they all have to work together, and I want dependency injection and cascading parameters. That's what you want.
Yes. I want it all.
Local storage isn't going to work for server-side.
I mean, let's be clear, Carl. So if you're 100% server interactive, there's no issue, because you can just use a scoped service.
Or 100% WebAssembly.
And if you're
global everywhere,
you
no
can
problem.
use a scoped service. It's when you're trying, but I like the new render mode, right? I mean, I think it's awesome that I can have a page that shows a bunch of data that's static rendered, because that's very fast.
Yeah.
And then I can switch to an edit page, which is interactive, and the user can do complex stuff, and then they can go look at another server rendered page that has complex read-only data. I want the best of both worlds. Absolutely.
Okay, so that was a nice little diversion. Let's get back to what we were doing here.
Right. So now what we've got to do is go look at your app state. And so what we're going to do then is I'm going to just add a class here, and we'll call it appstate.cs. And in appstate.cs, we'll actually do a little CSLA stuff here. So CSLA business types need to be serializable. That attribute is something that'll have to get removed because Microsoft is obsoleting all that stuff.
Awesome.
Which is fine, but we're going to inherit from business base of app state. And then we're going to create a property here, and we have an int, and it's counter value, right?
It's just count, actually.
Oh, just count. All right. So now we've got a type that CSLA understands how to transport back and forth.
Right. And as you said before, We haven't solved, or you haven't solved the cascading parameter issue yet.
No, that's
so,
right.
But we're just talking about raw state bags here.
Yep. I mean, people that understand CSLA look at this and go, oh man, you can use, there's a whole rules engine and all sorts of stuff, but we're just going to use, right now, we're just going to use it as a transporter for this one value.
Great. Yeah.
All right. So now I want to go back to counter, and we're going to get rid of cascading parameter because that's not how that's going to be, but app state. And then in this case, we want it to be equal to, I'm going to do things that you just are not supposed to do with CSLA, but this will work, I believe. Oh, no, it won't. That's right. All right. So we need to inject something called an iData portal of app state. This is a CSLA.
Bought one of those at Walmart. Doesn't work.
Gotta use CSLA, bring that. All right. So yeah, what this thing does is it knows how to do things like create instances.
So you're injecting session manager or iSession manager.
Yep. So I want access to the session.
Okay.
So here I can say, okay, I've initialized the state. So now I should be able to do get session. And now session is basically, it's just a dictionary. So now I should be able to say something to the effect of if session contains
key.
If it contains the key, then we want to say app state is equal to session app state. And then we'll have to cast it because it'll come back as a type object. Otherwise, if it's not there yet, now we're going to have to do equals await portal.create async. And then we can do session.
Oh, right, because portal is generically typed to app state.
Yes, correct.
Very cool.
Yep. And then the final thing that we have to do, since we're going to use the portal to do a create, we actually have to have the ability here. There has to be a method that the portal can invoke to create the type.
Okay.
And here we can initialize stuff if we want to. I suppose, we could say count equals 0 or something. That's redundant. Right. But let's double check. So now here we're incrementing appstate.count. And up here we're rendering appstate.count. So we still do need to do, because of the order of events here, we have to say if appstate is not null.
Because server-side render, it won't.
Yeah, and even with the WebAssembly, it'll take a little bit of time for it to load, right? So
right, okay.
Actually, I suppose what we can do is say if it is null, then
yeah, loading. Cool.
Okay.
And you disposing is taking care of saving it.
Yep.
Looks like. Save state.
So I don't know. Do we think it's going to work?
Yeah, go for it. Let's see.
Let's find out.
If it doesn't work, we'll have some more fun.
All right. So home works. We can go to weather. We can go back to home. Mm-hmm. Yay.
Counter.
Unhandled exception. Unable to resolve service.
Oh, HTTP client. I think you added an HTTP client, but it isn't initialized with the base address.
I think or maybe I didn't even add it at all. Let's go look at.
Yeah, and on the client, I don't think you did.
Oh, look at that. That's kind of a major oversight, isn't it? If I'm going to use HTTP client, I should actually.
There it is.
Have one of these available. All right. All
right. One more time. Got my toes crossed.
This one is. If if I click the right place, this one is initialized with the base address, so it should.
Yep.
All right. Okay, so now let's see what happens.
Okay.
Render mode WASM.
Let's click. Yes.
Okay.
Now here's the test.
Here is the test. So we go back to home. Go back to counter.
Yes.
And it works.
Whoa, whoa.
And of course, the cool thing is that session in home, we should be able to display that value too.
Right.
Right. Because it's a
in the
global
session
value that's available across all pages.
Right. And, just to be clear again, we do not need the cascading app state. The way that you don't inject it, the way that you get it is through the CSLA.NET mechanism.
Yep.
The way that you serialize it is through CSLA. And so it might be a little bit more painful than what you're used to, but guess what? It works.
It does.
You have the best of everything, Rocky.
Yep. Almost, man. If I could still have server pre-rendering on those WASM pages, that would be awesome. But that one I have not figured out.
Right.
And maybe it's not worth it, right? It's
maybe. We want to hear from you guys. If you have any comments or anything, you can, of course, go to the repos and the blogs, but send me an email, carl@appvnext.com. I'll forward things to Rocky, or he's rocky@lhotka.net, and, let us know what your challenges are and what your wish list is and all of that and how it's going. And thank you, Rocky. This is probably the longest Blazor train I've ever done, but it was so worth it because this work is incredibly valuable to everybody. Thank you.
You are so welcome. I will pair program with you anytime, Carl.
It's fun for me. All right. I'll see you. See you next time. Back to you in the studio, Carl. As I said in the intro, this episode is a time bomb. At some point in the future, it will all work and we won't need any outside help. But for now, let's all show gratitude to Rocky Lhotka for his diligent and difficult work. Thanks, Rocky. And thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blaze a trail!